Okay, this is the second part of the lecture of 15th of December, and the first thing to do is to ask you for some questions connected with the calculations that we did before the break. If some point is not clear.
I didn't understand why minus sigma square becomes sigma square plus sigma square.
Where?
And the last
somewhere on the whiteboard?
Yeah, on the bottom.
On the bottom. Where? Why this is plus?
Yes.
Yes, because in the integration by parts form we have minus. Let me show you. So here, before applying the integration by parts, we have another minus. This means if in the calculation here you have plus, here you have to put minus. If here from the beginning you have minus, you have to put here minus and here plus.
Yes, okay. I was missing this part. Thank you.
Yes, yes. There is minus from integration by parts. Minus by minus gives plus. Okay. Other questions? Now, I think with these calculations, we can turn to some concrete examples to see how we can apply the calculations of the variance and expectation. Typically, when you have normal distributions, we saw that our normal distributions are characterized completely by two parameters. One is mu, and the other parameter is sigma or sigma square sometimes is used to put the variation. Sorry?
We can see. We can see. Thank you.
Okay. So this is notation is normal distribution when we have random variable. That is normal distribution with mu and sigma square parameters. Then we know what is probability density. P of x. It is defined before the break with this exponential in which we have these two parameters mu sigma. Of course, this is big X, this is small x. This is x, small x varies from minus infinity to plus infinity. So, for example, if somebody asks you, what is the probability that, for example, some events happen of this type? X is bigger than 10. For example, if we know that the probability density of the distribution of virus is, X is the number of positive habitants of fixed village. If we need to find what is probability X to be bigger than 10, then simply we have to use this integral of the same p small x dx, but we set x bigger than 10. instead of writing from minus infinity to plus infinity, we need x bigger than 10. Therefore, plus infinity is the same, but instead of here minus infinity, I have to put here as lower bound 10. And then this integral, which p is concrete function, usually has to be computed. Actually, this type of integrals appear very often when we speak about weather forecast, the weather for tomorrow or next week. We have kind of normal distributions, and typically what is done, you make a kind of statistical evaluation, last, how to say, 10 months, make kind of normal distribution, compute your mu sigma, and then for the next month, you take this normal distribution and compute whatever you need, probability that the rain a square meter, the quality of the amount of the water on square meter is bigger than some quantity. Then you take your x and you have to take this integral. So it is important to have the possibility to compute explicitly, to know that this is exactly some concrete number. You cannot use always integrals. There is something that connects such normal distribution with one very basic normal distribution. The basic normal distribution is the following one, the one computed with mu 0 and sigma 1. For this type of random variable, this is specific random variable, let us call this random variable zeta, there is explicit specific tables showing you where you have, in this case, what is px. Let us remind this classical random variable, what is the density. This is 1 over square of 2 pi a to the power minus x squared divided by 2. And when you have integrals, I don't know if you can see, hope you can see now, integral from a to infinity of px, this is exactly 1 over square of 2 pi a to the power minus x squared divided by 2 dx. You have specific tables, and also there is already prepared software that gives you exactly the value of this type of integrals. So now we shall practically use without a specific expression. If you need, after this, we can make a simulation with software showing, I don't know, let us try if in Excel we have normal distribution. I think even with Excel you can try normal distribution. Let me see for a moment what is the situation with Excel if we have the possibility. Microsoft Office. Okay. And we have functions, normal distribution, auto sum, function clear, more functions. So average, No, I cannot see. Probably we have to be better informed. Of course, I have software with normal distribution and 0, 1, but if you have the possibility, Excel, normal distribution, we do the, yes, there is Excel normal distribution functions. Okay, and even with Coronavirus Institute homepage, I saw formula, normal distribution. There are some calculation based on Excel. So we have in web absolutely complete characterization, and with Excel we can try to find precise numerical value. Oh, this is standard deviation function that gave you, and this is function that is implemented in Excel, stdev. It is also norm dist is normal distribution function that is implemented in Excel, and there is command. Therefore, we can also say for our practical exam, you can use your Excel, and when it is necessary to make a specific calculation, and for normal distribution, compute this integral or opposite 1 over square of 2 pi integral. For example, if we need x to be smaller than something, we write minus infinity and this upper bound b, and then we have px dx. We can say that these or these integrals, they are very simply connected. The sum of these two integrals when a is equal to b is exactly 1. So if you have tables or if you calculate with Excel this integral, the value approximately, then the other guy is 1 minus this value. Now let us take generic case and see how we can compute this quantity, this random variable, and some probabilities associated with this random variable in connection with this standard normal distribution, because this here is with expectation 0 and mean by 1. So what is connection, roughly speaking, between x and zeta? For this, we shall need very simple thing. To know that when we have the density of this normal distribution, this was 1 over square of 2 pi sigma, and then we have a to the power minus x minus mu square divided by 2 sigma square. This was the distribution when we used the parameters mu and sigma. So what we can say about, for example, connection between x and zeta? Of course, if I, for the moment, change the variables, call this epsilon, or if you prefer better, zeta, well, this is my zeta, how we shall switch from variable x to the variable zeta? It is very simple. We have to take x minus mu divided by sigma shall be our zeta. In fact, the exponent can be transformed this way. And for example, what we can say about the our calculation that was what is probability that x is bigger than 10? I put 10 only for it. So this we know that this is exactly integral from 10 to infinity, and here we have px dx. But in this integral, we can make this change of variable. And if we make this change of variable, when x is 10, what is zeta? Of course, zeta, if we switch to our variable, we shall have integral. When x is infinity, zeta is plus infinity, so this is plus infinity. When x is 10, this shall be, zeta shall be up to 10 minus mu over sigma. And then I have to change variables here because I have this integral. So we shall have a to the power minus zeta squared divided by 2 dx. Dx will be sigma d zeta. If I write from here dx, the derivative of mu is a constant, so we cannot take into account mu. We have x is sigma zeta, so we have sigma d zeta when we change variables, and therefore we have sigma d zeta, but from here we have divided by square of 2 pi times sigma. So after changing of variables, we replace our integral by the following one. And you see the magic cancellation, sigma with sigma. And actually here we have the our standard normal distribution with a to the power minus zeta squared. Then I can write that this is probability that zeta is bigger than 10 minus mu over sigma. And of course, for this guy, you can use Excel and find your normal distribution because mu is given, sigma, and therefore you can find your exact probability from the tables of the normal standard normal distribution. It is clear that this calculation can be generalized, but before doing this, let me ask you, this example, this line is clear what we are doing, how we switched from normal distribution with parameters mu sigma square to the standard 0, 1 normal distribution. With this effective part is this change of value. So if you have
Sorry, when we define the p zeta, then the change in the change of variables, why in the in the denominator there isn't sigma? I don't understand.
You don't understand this?
Yeah, why in the denominator?
we have square root of 2 pi.
Yeah, but why there isn't sigma?
Because we said sigma is 1. The standard distribution is with sigma 1. This is what is known. You can find even in books, tables, but sigma is 1.
Okay, thank you.
Sigma is 1. And as you can see, for example, here you have mu sigma dependence. This is mu sigma. But as you can see here, thanks to this cancellation sigma and sigma, sigma disappears, and this is perfectly the standard one without sigma. Sigma is 1 here. So we get our standard distribution zeta, that is with sigma 1.
Okay, thank you.
You're welcome. Okay, other questions? I think actually here it is clear that we can replace this 10 by any real number a, So the only difference is that here we have a, and here you have a. So when you want to compute your any normal distribution with parameters mu sigma, to compute probability that your random variable is bigger than a, you simply have to use the standard normal distribution and write this quantity that replaces your lower bound. So we can, in this case, say using this relation, but now using capital X and capital Zeta. Formally, we can write capital X minus mu divided by sigma is your zeta. So this means when you take probability that X is bigger than A, this is equivalent to say that probability of X minus mu divided by sigma is bigger than A minus mu divided by sigma. And we know this, according to our calculation, is exactly the zeta standard normal distribution. And this is the formula that we already, zeta bigger than A minus mu divided by sigma. This is the relation that we obtained that can be established also in this way. Okay. Now, let us take the other concrete example to show you how effectively we can use the normal distributions in order to make kind of this is not weather forecast, but how to say, to prevent, for example, what shall be the behavior of infected people in January, for example. We shall take the data in last 8 months, assuming we have normal distribution. So the example is the following. Suppose that you have X to be normal distribution describing the number of people infected by coronavirus last 2 trimesters. For example, we have, let's say, no, last trimester, 3 months. The period is 3 months. For 3 months, some statistical experiments are done, statistical data. On the basis of this statistical data, the scientists made the assumption that we have propagation with mu and sigma given. We can take mu equal, depends, we have in this case number of people, and we can say, for example, in some village this is 60, and sigma we shall take some quantity, something like 4. Okay. We know that last 3 months propagation is like normal distribution with these parameters. Now, we want to introduce x1 shall be random variable describing people that are infected next 3 months, so January, March, and x2 random variables from April, the next 3 months, June. And we suppose that these are 2 random variables having the same normal distribution. Of course, this has to be verified, but our purpose is to compute probability of x1 plus x2 to be smaller than 40. Actually, we can put here a little bit more, 140, because for 3 months, 60%, small village, 60. Then when we take the sum, we need to compute probability that these 2 independent normal distributions, random variables, they shall describe the next 6 months, and we want to see in the next 6 months probability that the number of infected people is bigger than 140. So here it is very important to understand what is x1 plus x2. Of course, we know that x1 plus x2 is again normal distribution. If it belongs to the same parameters mu sigma square, x1 and x2, what we can say about the expectation of x1 plus x2? Can you help me? What was the proper expectation? Yes. This was very, very important property.
If they are independent.
As I said, they are independent.
So we have the expectation of x1 plus the expectation of x2.
So this is 2 times the expectation of mu. Okay, this is very good. So this is normal, x1 plus x2 is normal distribution. But what we can say about the variance of x1 plus x2? Remember, for normal distributions, what we can say is we use in the law of big numbers. Remember this. You can take a look. Yes. Can you remember? We had very important property of the expectation and variance. Do you have some trace of our lectures? To take a look. This is really very important.
Variance of x1 plus variance of x2.
Yes, this was important relation. This was connected with the definition. This was the expectation of x1 plus x2 minus this squared minus expectation of x1 plus x2 squared. But the important thing for the expectation of, for example, here we have expectation of x1 squared. x1 squared plus 2 times expectation of x1, x2 plus expectation of x2 squared minus, and here we have minus expectation of x1 squared minus 2 times expectation of x1, expectation of x2, and then we have minus expectation of x2 squared. Of course, this is variation of x1. This is variation of x2. But these guys, when we have independent events, their difference, we said, this is covariance, and covariance was 0. Independence was equivalent to the fact that these guys were cancelled. So you're right. The important property of the variance is additive property. So we have 2 times sigma square. And now you can very simply compute this quantity. This is to remind you what we have done before. A little bit small part of the theoretical preparation should be used. And now let us compute, because this now is normal distribution with parameters 2 mu and 2 sigma square. So, according to our calculation before, P of x1 plus x2 bigger than 140. This is probability of zeta to be bigger than 140 minus what I have to write here, minus, yes,
Minus mu.
not mu, 2 mu, because x1 plus x2 has parameter 2 mu.
We cannot see in the, we cannot see the exactly.
Yes, please. x1 plus x2 has parameters 2 mu and 2 sigma square for the expectation and variation. So here I have to put 2 mu divided by, it was sigma. Now sigma shall be square of 2 sigma, because this is square of something, square of 2 sigma square. So I have to put the new sigma is square of 2 times sigma. And if mu and sigma are given, you take your values mu sigma, compute this quantity, and then for this you see zeta is standard 0,1 distribution. And for this standard 0,1 distribution, you have tables, you have Excel. So from here you compute explicitly the numerical value of this quantity, and you have precise example where we use theoretical part and we reduced our probability to the concrete numerical calculation. Let me ask you if this part is clear. I think we need a little bit, especially for the preparation of our example, I need also to repeat some of these examples in order you to have more experience, because unfortunately we haven't enough time to cover with more exercises our practical part. Therefore, I should advise you for the concrete calculation connected with normal distribution to have the possibility to use Excel and or some other, I think also in any calculator in your standard mobile phones, there will be something connected with this thing. But Excel, I think, is something that is very often used also in high schools. Therefore, you can trust to this application and make the calculations till the end. Okay. So these were the calculations that for today I plan to do. I can pose you a few exercises to prepare and make similar calculations. So one of the things connected with coronavirus is impossibility to be absolutely sure that this shall be Gaussian distribution. We can have also another distribution that is exponential. So we have exponential random variable. And this is very simple. P of x can be defined in this way. A to the power minus x when x is bigger than 0. 0, of course, with some constant when x is smaller than 0. This thing can be generalized putting here a parameter lambda. Lambda is something positive. And of course, in order to compute your integral, it is simply the constant is 1 over lambda. So this is one of the exponential distribution that also is very often used. And of course, for this, I pose the question to make calculation showing what is the expectation of x, what is the variance of x, and then to, for example, repeat what we have done. If you have x1 and x2 independent exponential random variables, what is probability x1 plus x2 to be bigger than some fixed constant? So these three questions form a series of calculations for this distribution. Another variant is P1 of x, that is defined like a to the power minus lambda. Here we put absolute value of x, and then we have y by 2 lambda. So this is the definition of Px for x in R. And then again, we have the same questions to calculate the expectation, the variance, and for from point of view of many models, this seems more adapted to these epidemiology models, and that's why I suggest to consider these examples. Therefore, these are several examples that you can take and try to solve, and then we can discuss during our possible meeting in Teams for preparation of the exam. Okay, so I am planning to ask you a question. If you have questions, to tell me if you have some proposal for this appointment. If not, you can send me also by email, by Teams. And
Professor, excuse me.
Yes.
I was thinking this the next week on the 22 and the 23
Yes.
in the same hours we should have lessons. So, for example,